Hey folks, welcome back for another episode of Code Club. In today's episode, I'm going to show you how you can make this figure using the tools from ggplot2 and related packages in the tidyverse. That bar plot, it was taken from a paper published in Applied and Environmental Microbiology back in October. It's from a paper titled Strategies for Effective High-Pressure Germination or Inactivation of Bacillus Spores Involving Nisin. It was published by Rosa Heidenreich and colleagues. I'm sorry, Rosa, if I'm butchering your last name. So as the title indicated, this paper deals with methods of destroying bacillus spores. Why do we care about bacillus? Well, you may have heard of an organism named Bacillus anthracis. This is the organism that causes anthrax. And other related bacillus species can cause all sorts of other problems, and so in generally we want to kill them. It's also a model organism for other organisms that create spores, these states of life in bacteria that are very difficult to destroy. And so they were interested in using high pressure to get them to germinate or to inactivate, and then using nisin or not to get them to germinate or not. And so we are going to be looking at the inactivation or the destruction of those spores. So in the caption for the figure, they indicate that the heat treatment was 80 degrees Celsius for 20 minutes. And so they had cultures that either didn't receive that treatment or did receive that treatment. And that they then had looking at nisin or not, which is kind of the second line in the axis labels, whether or not it received high pressure or not, that's the no HP, or that did receive moderate high pressure, and so that moderate high pressure is 150 megapascals, or very high pressure at 550 megapascals. Okay, and so that's this third line in the captions. So then the first line it tells us in this is the valine was added, or whether or not TSB, tryptic soy broth, was added, and then in this fourth condition, they heated it at 80 degrees Celsius for 10 minutes and then incubated at 37 for 6 hours to basically get the cells to germinate before they hit them with another high pressure blast, which is that second VHP. Okay, so this kind of gives a little bit of a description to what is going on in all these labels. I know it gets a little bit confusing with all this jargon that they have in. One of the challenges with scientific papers is that we have very complicated experiments that we try to describe in kind of a pithy statement. The problem with those pithy statements is that you lose a lot of information, and so it's not immediately clear what's going on. And so, of course, we have these figure captions. The other thing that we see is that the error bars present standard deviation of independent experiments of 3 or more. And also there's a dashed line indicating the detection limit. And so, yeah, we have these bars. And we can think of kind of the limit on each of those, the bottom limit, as being the mean plus or minus the standard deviation. The y-axis then is the log base 10 ratio of the number of cells divided by the total number of cells that were used in the experiment. And I think back here, they also told us that N0 was 10 to the 9 CFU per mil. So if you had a value of -7, then that would mean that N was 10 to the 2, right? So 10 to the 2 divided by 10 to the 9 would give you 10 to the -7. And so then log 10 of that would get you -7. And so their limit of detection, of course, was -8 because you perhaps couldn't get down to single digits of cells being counted the way they did their dilutions. So a few things stick out to me about this figure that are a bit different from what we get with kind of normal vanilla, if you will, ggplot plots. So let's say what it is, right? So if this is a bar plot, and so we typically think of bar plots as being positive, and I think what caught my eye was that these go negative. So instead of being high, these are deep, right? And we have the mean, the depth is the mean of 3 observations or more from 3 independent experiments. The error bar, as the description said, represents the standard deviation of those independent replicate experiments. The x-axis are the different treatment groups that we discussed as being the different ways that they went about trying to kill those spores. They used a heat treatment or not a heat treatment. They did the analysis before and after the heat treatment. That is, the dark blue is before, the light blue with the diagonals is after the heat treatment. The y-axis then is kind of a log scale It's a negative scale because N is the number of CFU per mil that they found after all these treatments, divided by 10 to the 9, which is the N sub 0. And so whenever you have a small number divided by a large number, and you take the log 10 of that, you're going to get a negative number. And so if there had been no killing, basically if N0 over N0, the log 10 of that would be 0. And so we see that they've got a 0, basically the axis line up here at the top, and they also then have this dashed line indicating the limit of detection. So that's kind of the layout of the plot and basics of what they're trying to say. So a few design things stick out to me. So first of all, one of the things that I think is pretty cool is that normally the legend would be in the right side of the plotting window, off in the right margin, taking up lots of space. And it's fortuitous that this fourth group had such a long description because they were able to neatly tuck the legend in kind of in this pocket within the labels. So I thought that was pretty cool. Something else I noticed about the x-axis labels is that these tick marks go up into the plot. Normally we see them with ggplot going down out of the plot or out to the left. And also on the y-axis then, they don't have any tick marks, but they do of course have these horizontal light gray grid lines in addition to this dashed line for the limit of detection and the axis for 0. Finally, I noticed that they have these diagonals, the hashing for their after heat group. In general, we don't see a lot of hashing in modern data visualization. I think this type of hashing was more common back when we actually had to pay extra to publish papers in color. There's really no need for the hashing in this figure, I would say. You have a dark blue for before heat, light blue for after heat. So why they added the hashing, I don't know. I will give you a spoiler. In today's episode, I am not going to do the hashing, but we can do the hashing. And in the next episode, I will show you a couple of ways that we can pull off that hashing effect. Whether or not you actually want to do it for your own visualization needs, I'll leave to you. But I am going to do my best to recreate this figure today, doing everything except worrying about the hashing. So I have simulated the code to the best of my ability in this spore data tibble. If you want to get this code that I'm starting with, as well as all the code that I generate in today's episode, go down below in the description for today's episode. You'll see a link to a blog post, and that blog post then has all the nicely formatted code that I will be writing and sharing with you today. Let's go ahead and highlight and run everything so that we have our spore data tibble stored in our studio. So if we look at spore data, we see that it has 3 columns: the fraction alive, the heat, and the treatment. And so the treatment, I have A, B, C, and D instead of kind of those long labels. We'll replace these later when we do scale X discrete. So hold on for that. And then our heat was how we had those columns dodged, right? Because we had before and after the heat treatment. And then this fraction alive is the fraction of cells that were still alive after whatever the treatment was, regardless if there was heat or not, okay? So spore data has 24 rows to it. I could see all 24 if I do spore data and pipe that to print. I could do n equals 24, and this then will print everything out. Alternatively, if I didn't want to put 24, I could also do inf, and I'd see everything there as well. And so again, the plot shows the mean plus or minus the standard deviation. Something that I might do would be to do something like spore data group by, and then do heat and treatment, and then summarize, and we'll do, I'll say like mean equals mean on fraction alive. Yep, and I'm missing a closing parenthesis there, right? And so then this would give me the fraction alive for each of the 4 treatment groups with the before and after heat, right? So what I might do with something like this is to save it to a variable and then take that variable and pipe that into ggplot2. I'm going to show you a better way. In previous episodes, I feel like I've been showing you how to use stat_summary to make kind of all sorts of different types of plots. And so I'm going to use stat summary here as well, so that I don't have to worry about that intermediate variable storing the summarized data. And we'll get the same type of effect. So let's go ahead and pipe this to ggplot, and we'll do AES. On the x-axis, we're going to want to put the treatment, and then we're going to have a fill on the x-axis for the heat, And then our y is going to be the fraction alive. Running that gives us a very clean plot here. One thing that I'm noticing is that we have the fraction alive rather than the log fraction alive, right? So to replicate what they had, I can go ahead and take the log of the fraction alive. And so I'll then do mutate log fraction alive, and that will be then log 10. So if you use log function on its own with just log, you'll get the natural log. But if you want log base 10, use log 10. I think there's also a log 2, but log 10 and log are the most commonly used ones. So again, we'll do log 10 fraction alive, and then we'll pipe this into ggplot. And of course, I'm going to use log fraction alive instead of fraction alive. And now I see in this plot that doesn't have a plot that I have those negative log values like we had in the original figure. Now what we're going to do is go ahead and add to this stat underscore summary. So we have to give stat summary a geom. And for that then, we'll then say call. So now what we get are the columns, right? And so you'll see that by using stat summary geom call, we've replaced having to do that group by summarize and using geom call, okay? And the same arguments that we would have given to geom call, we can put in here into stat summary. And so one of those that we want to use is position dodge, because right now our bars are on top of each other. And so we'll do position equals position dodge. And that dodges them left and right. So that is looking good. And one thing that I'm noticing is that when I run this, I get a function that says no summary function supplied, defaulting to mean underscore SE. I want mean underscore SD, but there isn't a mean underscore SD. So I need to make a function that I'm going to call mean underscore SD. Let's say function. And then let's get some space here. So these functions that we give to stat summary need to return a tibble with the y value, the y min, and the y max. And so I'll do tibble y equals mean of x. And so x is going to be the vector of data that come in. And then y min is going to be y minus SD of x. And then y max is going to be y plus SD of x. Okay. Now this y, I could have said mean x here, but I already have the y column, so what's the big deal? So we'll go ahead and do that. And now in my stat summary, I'll go ahead and do fun.data equals mean underscore SD. Now we see that we don't get any message here, and our plot hasn't changed, well, because we're still getting the mean, and what I was changing was the standard deviation instead of the standard error. And so we need to add the error bars. So we can add those error bars using very much the same syntax as we used here with stat summary with geom call. Instead of geom call, I'm going to use error bar. So now we have the nice error bars added to each of the bars of our bar plot, and we're well on our way. I'm going to go ahead and save this now out to a file because I'm going to be starting to move things around, and I always like to have things encapsulated in a file, the file size that I know that I'm going to use for my final presentation. When I do things in the lower right corner and start moving things around and then save it, then things always look a little bit funky. So I'm going to go ahead and do ggsave, and I'll call this negative bars.png, and then my width. So I'll make my width 4, my height 5. And so here is what our figure looks like relative to the original. We have a fair amount of work to do, but we'll get there soon enough, don't worry. So the first thing I'm going to do is to go ahead and shrink the width of those error bars. And so let's clean things up here a little bit. Let's do width equals 0.25. And so those are perhaps too narrow and they've been moved in. And so we'll have to move both the dodge width as well as the width of our error bars. And so let's make our width of our error bar 0.5. And I think that looks pretty good. And so then we need to dodge things out a little bit more. And so let's do width equals 0.5. That didn't help. let's do 1 and see what that gets us. I think that looks pretty close, although this I can see is a little bit too far to the right, and this is a little too far to the left. There, at least on this one, there's more teal to the left than here. Let's go ahead and make it 0.9. And I'm going to call that good. I think that looks pretty much right dab in the center, and that our error bars are pretty much the same size as theirs. That looks pretty good. Now let's go ahead and turn our attention to our colors as well as our legend. The first thing that I notice is that in my legend, it's going alphabetical. So after, before, before. And I went before, before, after. So many befores and afters. Anyway, so we can change this by setting heat to be a factor. And so let's come back up here into our mutate statement, and we'll do heat equals, so we'll do factor on heat, and then we'll do levels, and then it's going to be before heat, and then after heat. And now what we see is that before comes before after, and that before is on the left side of each of these columns, right? So good, we're gaining on it here, right? The next thing I want to do is to modify our color. So to change the colors, we'll go ahead and do scale fill manual, and we'll do breaks of before heat and after heat. And then our values, we're going to put in 2 bits of hexadecimal. Using my digital color meter, I'm going to go ahead and try to replicate the colors as faithfully as I can. So I'll grab that, and the before heat will be that dark blue, and then this after heat will be this lighter blue. Plop that in. And so now we see that we have the same blue shades that they had in the original figure, which looks pretty nice. One thing I noticed that with theirs, they have a black border all the way around both of the bars. And so I can add that black border back up here with my stat summary by doing color equals black. And so now I get that nice black border. It's perhaps a little bit too thick. And so we can come in here and do line width. Let's do 0.25. And so that's a thinner black border, which I think looks pretty good. We might adjust that later, as I frequently do. I don't want the label on the legend, so I can get rid of that here in scale fill manual. I can do name equals null. We've seen that we can also remove the label for that legend in the labs function, but we've got scale fill manual, so we'll do it here. So now we've gotten rid of that. So of course their legend is down below their treatment at the bottom of the plot. I'm going to go ahead and hold on for that for a minute and come in and change the x-axis labels. And so we can do that with another scale. We'll do scale discrete, and we'll do breaks of A, B, C, and D. And then our labels will be those long labels. So hold tight for a minute. I'm going to go write those in real quick, and I'll be right back. All right, so we added those 4 labels for those 4 treatment groups. Oh, and it's supposed to be scale X discrete, not scale discrete. And so now I have these nice labels on the x-axis. So let's go ahead and remove this treatment on the x-axis. And I think I can do that in scale X discrete by doing like name equals null and clean this up. Yeah, so that got rid of the name on the x-axis. Looking good. So let's go ahead now and take the legend and plop it down here in this space. So this is going to take a couple of steps. So we'll start by adding our theme. We'll do theme classic. So now we see we've gotten rid of all the grid lines and the background. We can then add to this theme. And now we're going to do a variety of additions to theme for the legend. So we'll do legend.position. We'll do bottom. And so now we can see that we have our legend on the bottom, but it's side by side rather than on top like the original. And so we can do legend.direction equals vertical. So when we move it to the bottom, it makes direction horizontal. When it's over on the right, like we had it originally, it was vertical. And so now we see that it's vertical. Theirs was moved over to the left. We can do legend justification equals left. And so now we see that it's over to the left, okay? One thing I'm noticing is that our plot is somehow got more narrow than theirs. So I think originally I had 3.7 and 5.2. It must have changed somewhere along the way. And so now we see that the plots are basically the same size. So let's do some theming on our legend. We'll notice that theirs has a background around the legend box and that the font is italicized. So let's go ahead and do both of those. And so we'll go ahead in here and we'll do legend.text equals element text, and I'll do face equals italics. And I think it's italic, not italics. So to add that box, we'll go ahead and do legend.background, element rect, color equals black. And so now we get a nice black background. The padding or the margin around the box compared to the keys and the text seems a bit wider than what they had in the original. So we can modify that by doing legend.margin equals margin. And let's put it at 1 all the way around and see what that looks like. So that's pretty tight. Maybe we can be a little bit wider. So let's try 2's all the way across. So I think that looks pretty similar. Their keys are wider than they are tall. And so we can change that with the legend key, height, and width. So let's do legend.key.height, and it'll be unit. And so that's the height. So let's go ahead and make that 10 points. And then the legend.key.width, let's make that unit. Let's try 20 points. And so that, I think, is pretty close to the same aspect ratio. Their font, of course, is quite a bit bigger than ours. So let's go ahead and make the font bigger so we can kind of match what theirs looks like. And so we see that with legend text. In here, we can do like size. Let's try 12. We can probably go even bigger than that. So let's go up to like 15. Maybe let's try 13 and we'll call that good enough. And our key height can probably be even bigger to get more separation, okay? And so now let's put this up to like, say 15 and 30. And I think that looks pretty good. So I think that looks pretty nice. And our legends looks fairly similar to what theirs looks like. Of course, their x-axis font is a bit bigger than ours as well. So let's go ahead and try to increase that. So it looks like their font is perhaps a little bit smaller than what they have for the legend. So we'll go ahead then and do axis.text.x element text. And then we will then do size equals, and let's try 11. And so now we see that it's perhaps a little bit small, but I want to go ahead and move this up into this pocket before I fiddle with those sizes too much. I also notice that this color is grayish, not so black. That always annoys me. I don't know why Theme Classic makes it gray rather than black. Anyway, let's go ahead before I forget. We'll do color equals black. And while I'm here, I may as well put this up to 12. And I'll do the same thing for the y-axis, making it have the same font and the same color as what's on the x-axis. So let's now go ahead and move this into the pocket. And we can do that, again, back here with the legend arguments. We'll do legend.box.spacing. And this controls the spacing between the legend box and the rest of the plot. And so here we can do unit. And if I do 0 points, let's see what that looks like. That then makes basically no space between the bottom of the x-axis labels and my legend. And so if I make it positive, so if I used like 10, it would move the legend box further down, more spacing. If I make it negative, it's going to move into this pocket. So let's make it, let's do minus 15. So we see that moves up in. Let's go ahead up to 30, and that moves in rather nicely. I think that looks pretty good. We also want to bump this over to the right a bit, so it's kind of almost justified on the left side of the val and nis here. And so we can do that also with a legend argument. So we'll do legend.box.margin, and we'll then give that the margin function. And the one we want to change is on the left. So we'll do left equals 10 and see where that gets us. So that moves it over a bit. Let's go ahead and be a bit more aggressive and try 30. We're getting there. Let's keep going. Let's go up to 50. And I think that's right where we want it, right? So now we have our legend tucked right into this pocket made by our text. So let's turn our attention now to the y-axis. And so we'll come back up here to our scales. So we'll do scale y continuous, and we'll do limits equals, we'll go from -10 to 0. And so now we see that we go 0 to -10, but I want them to be on integer values, right? And so to do that, we'll use the breaks argument. We'll do breaks, and we'll do seek 0 to -10 by ones. And I'm getting an argument complaint. Wrong sign in by argument. Yeah, I guess if I'm going negative, I should be doing this down by -1. So that looks pretty good. One thing I'm noticing is that their 10 is right at the bottom, and we can get that by using the expand argument in scale y continuous. So we can do expand equals c 0, 0. That puts our 10 right at the bottom, but it also doesn't have a line going above the 0. So why don't we go ahead and make our limit go from 0.5 down to -10, so that we kind of trick it into adding a little bit of that y-axis. So again, back up here, we'll add 0.5. Very good. That gives us our line going up above it. So maybe the next thing we can do with theming is to remove those tick marks. And I recall that I didn't change the tick marks on my x-axis, so we can do all that. So we'll go ahead and do axis.ticks.x element blank. And that got rid of my x-axis. I wanted to get rid of the y-axis. I get tired. Now we've lost the y-axis ticks. Looking good. Now let's get those x-axis ticks going into the plot. And so here then we can do axis.ticks.length.x, and this will take a unit. And so if we do like 10 points, then we get long ticks out. But again, like we saw with the legend box spacing, if we get of a negative value, it'll go into the plot. So let's go ahead and do that. So let's actually do -8, because I think 10 is perhaps a little bit too much. And so now we have our x-axis tick going in, and we might even be able to shrink it a little bit. Let's go ahead and plop that down to 5, and I think that looks all right. That's great. So let's return to our y-axis, and we want to give a good title for our y-axis that matches what they have over here. In here, in scale y continuous, we could again give it a name. This is a little bit weird. I'm usually used to naming my axes using the labs function, but for whatever reason in this episode, we're doing it in the scale. So we'll do log. So we're going to use HTML to get the subscripts and superscripts to our data. I guess we don't have any superscripts, but to get our subscripts. So we'll do sub 10 on that. And then it's going to be the ratio of n divided by n sub 0. And we'll escape out of that tag. And then they had this square brace with a hyphen in the middle. And yeah, that should match it. I think there's maybe a space here between the log and the ratio. Good. I'm not a big fan of using units as axis labels. I think it would have been far better to say like log fraction killed and then kind of put the units there. But anyway, I'm trying to reproduce their figure, not my figure. Then what we need to do is to go ahead and in here for our axis text, let's go ahead and do axis.title.y equals element markdown. And element markdown comes to us from ggtext. So I need to go ahead and add library ggtext. And then let's go ahead and run all this. Now we've got the subscripts looking good. This is a little bit smaller than what they had. So let's go ahead and make that a bit larger. So here we can do size equals 12, maybe a little bit bigger. Let's go up to maybe 13. And I think that looks all right. So they've got a bit of margin on the left and no margin on the right. I guess what we could do would be to do something like plot.margin. And we could again do margin. And then the margin on the right could be 0. And on the left, we could make that say 20. Yeah. And so we have no margin on the right and we have a bigger margin on the left, right? Cool. I noticed that there is a bit more spacing between these x-axis labels and the axis. So we can change the margin in our axis text x by giving it a margin argument. So we'll do margin equals margin. And then the top, let's go ahead and make that 20. Okay, that's a lot. Let's reduce that to maybe 5. Okay, we can go up to, let's try 8. And I think that looks pretty good. Their font is a little bit bigger than ours, which is, I think, why things are kind of writing a little bit lower. I'm noticing that when we moved the legend to the bottom, our whiskers got a bit wider. So we could perhaps shrink that down a smidge. So we have that here with the stats summary. Let's go ahead and make this 0.3. And I think that looks good. I think that's about the same size as theirs. I like that. Now what we need to do is to add the horizontal lines. We need to add the grid lines. So let's start with that. That we can actually do in the theme. So we'll do panel.grid.major. and we'll do element line. We'll do color equals gray, and it's unhappy because I forgot a comma here. Oh, that's all the grid lines. I only want I think the Y ones. I get the X and the Y confused. Okay, Y, good. So now we have those grid lines. Theirs is a bit thinner than ours. We can go ahead and knock that down a little bit by doing line width equals 0.25. Now we need to go ahead and add the horizontal lines at 0 and 8, minus 8. And it looks like their grid line is on top of the bar. So we want our geom h line to be run after our stats summary functions. And so we'll come back up here and we'll then do geom h line and our y intercept to be 0 and minus 8. Very good. We now have our 0 line and our negative 8 line. That's good. The 8, I think, should be a little bit thicker, and we also want it to be dashed. So let's start with the thickness. And so we'll do geom h line, and then we'll do line width equals, and so we're going to give it a vector. So you could run 2 geom h lines and do 1 for the 0 line and 1 for the minus 8 line, or we could do it like this, where we're just kind of doing it in one function and give it vectors, right? And so 0 is going to be the first one. So let's leave that line width, I think, at 1. And let's make the dashed one, the minus 8 one, let's try 2. Okay, that's pretty thick. I think our minus 8 should be 1 and our 0 should be 0.5. So let's come back up here and we'll make this 1 and this 0.5. That's great. And now we want to add dashing to our minus 8 line. And so let's come back up here. And in here then, we can go ahead and do line type. And we'll do solid and then long dash. And that gets us long dashes. It's maybe a little bit longer than their dash. So if we take that and maybe make it dashed instead of long dash. Yeah, I think it's dashed. That looks pretty good. And this might be a little bit thicker than theirs, but who knows? I think it looks pretty good. Yeah, I think this looks like a pretty good reproduction of theirs. I might fiddle with the font sizes a little bit and moving things around, but I think for the most part, we've got it. We know where the differences are, and I'm going to be pretty content with the way this looks. The one thing that we don't have in this figure, however, are the hashings. And so this video is already going to be kind of long, and so I'm going to save making those hashes for the next episode. But I hope that you can look at this and see that the hashings are really unnecessary, right? We don't need those hashings because we have 2 variables, right? We have a dark blue and a light blue. It's clear that that's before and after heat treatment. So I just think that that hashing is an extra layer of ornamentation that we really don't need. So regardless, people like to have hashings. People have crazy PIs who tell them, no, we need to have hashings. And then you kind of do what the boss says. So the next episode, we'll come back and do those hashings. Again, there was a lot going on in today's episode, from using stats summary to summarize and plot your data all in one full swoop. A lot of theming going on to modifying the location and the appearance of the legend. A lot of stuff going on with axes, as well as drawing those grid lines, as well as making these axis lines and limits of detection. Lots going on. Encourage you to go back and watch it again. Certainly encourage you to share this with your friends. Try to make the plot yourself. And of course, down below, there will be a link to the blog post that has all the code from today's episode. Because I can't help myself, I will probably update the font sizes to more closely match what they had in the original figure. All right, that's all I've got, and we'll see you next time for those great hashings and for another episode of Code Club.